Hello, folks. My wife tells me I should be doing something called resting. I don't know what that is, so instead, I'm going to give you an update on our Model 3 PCS working, hacking, cracking, whatever you want to call it. But, spoiler, Elon is handing me my ass on this one. So let's go and we'll have a look and see what I have found out and what we're going to do about it. Alrighty. So what we have for you now is the PCS is now waking up, as I will demonstrate. Ooh, look at that. Look at those nice flashing lights. Elon, you are awake. Now, turns out that I had been majorly wrong in the last video when I said that the low voltage supplies were being derived from the high voltage. They're not. The low voltage supplies on this board are derived from 12 volts applied to the DC-DC converter input terminals. Now, to wake up the unit, what you need to do is you need to ground the wire that is designated PCS enable. Now, I know, right, you're thinking, duh, okay? But I had been grounding that. The problem is I was grounding it to the wrong ground. You see, in our little wiring harness here, we have something called PCS ISO ground. And of course, naturally, moron here thought that all of the lines here would be referenced to PCS ISO ground. Turns out they're not. PCS enable, when I got into the guts of the HV controller here, is grounded to chassis ground, which it gets from just under the American flag there, a nice bolt going into the case. So once we ground wire W02 from the harness to ground on the DC-DC converter, we get the PCS to wake up for us. Now, so we're thinking, whoopee, PCS is now awake. So, first thing we then want to do is see what interesting info that we can find on the CAN bus. Now, according to our wiring diagram, there are two CAN buses. One is called CP CAN, which I assume stood for charge port CAN, and the other one is called IPC CAN. Now, both of them come through the wiring harness back to the HV controller. What then happens is, if we wake up the PCS, but we do not have the HV controller connected, we don't get any messages from the PCS. It just basically sits there and does nothing. So, if we then connect the HV controller up, it starts pumping out a unmerciful load of CAN messages, particularly on the CP CAN. It in fact puts out over 2,500 frames per second just by itself, sends those down the line to the PCS, which then responds back with not as many. It's got about a dozen or 15 frames that it sends back here. Now, so far, what I have determined at a first glance is that the CP CAN messages from the PCS don't contain any reference to high voltage battery, at least that I could see on a first glance just by varying the HV that I applied to this and trying to see if there's any change in the messages sent from the PCS over CP CAN. Now, naturally, you're now going to say, okay, well, what about IPC CAN? And that is where things take a little bit of a walk on the wild side. Let's go have a look. Okay, so let's have a look at a little snippet of the wiring diagram here. Now I'm hoping this is going to come out because the screen recorder I have is crap, so fingers crossed this will actually work. Now this is the PCS side of things here, and this is the HV controller here. Now this is the wiring harness that we just saw there that goes from PCS to HV controller. Now this is PCS and enable L, that gets us to wake up. Now here these two pin 10 and pin 11 are CP CAN, TCVR P and TCVR N. These are a twisted pair and they work over standard CAN level at 500K. I can connect to that with a CAN DUI and we can read messages there, no stress. Now, this IPC CAN PCS RX and IPC CAN PCS TX are where things get a little bit weird. Now, there is no CAN transceiver involved here. On the PCS side, these arrive into U22, which is a ISO 7741 high-speed digital isolator. I have to have a quick look on the HV controller and see where they end up there, but I'd imagine it's probably something similar. Now, the voltage levels on these channels, IPC CAN PCS TX and IPC CAN PCS RX, are again not CAN levels, they are 5 volts. Now I'm going to show you on the scope here. Basically this is IPC CAN PCS TX. Now what you're going to see there, hopefully, is that we've got voltage that it seems to be going from slightly undershooting the ground to going quite a bit above ground. Now a bit of that could be this scope. It's not exactly a high speed kind of a device. It's not really able for, I think, this kind of modern high speed electronics. Now there's a look at, so this would be what is coming from the PCS to the high voltage controller, at least that I can work out. Now let's take a look at what comes from the high voltage controller to the PCS. So we'll come over here and change our scope onto this wire. Now you're going to notice a completely different kind of a waveform. Now I haven't touched any of the oscilloscope settings, but this is a much richer waveform, and it's not hitting ground and it's not exceeding 5 volts. Now when we then go ahead and connect what I did here is I got myself an Arduino DUI just with a little CAN to serial program in there. Got my CAN1 receive and just basically went in here on the digital isolator. Now when I do that, here we go. When I do that, I get myself some nice CAN data. So I get all these messages like 70A, 152, 12A, all this. And that's fine. Now, when I then move to, so this is data from the high voltage controller to the PCS, at least that I understand. And when I then change over to PCS to high voltage controller, I don't get any data. Damien, I hear you all cry. That may not be CAN. What could that be? Could the Musk be possibly lying to us? Well, he could be. So what I decided to do then, when I was seeing all this weirdness, was to connect my cheap and cheerful Saley logic analyzer to the two lines and see if we could do ourselves a little bit of protocol decoding. So I assigned channel 0 here is from the HV, or from the HV controller to the PCS, and channel 1 from PCS to HV controller. And I selected CAN for protocol decoding, just as I tend to trust Elon. And when we do that, we tend to get valid CAN messages here. Actually, this is a little strange. Now, keeping in mind these will be decimals, so 1900 is, I think it's 7C0 or something like that, which is a message that I've seen on the high speed as well, or on the not the high speed, this is weird. Now I'm seeing the same message here. Okay, so what I did think when I saw this the first time was that this one was some kind of a clocking signal for, you know, these frames, but I don't think that's the case. Now I'm put the, you know, so there's a message there, 1802, you know, decimal 8, and then there's the various data bytes. Now, as we could see on our scope, there's a lot more data seems to be going to the PCS from the HV controller than seems to be coming back. Now these here, I'm not 100% sure about what they represent, but the fact that my Arduino DUI is not understanding this is a bit weird, so I really don't know what that protocol is about. If anyone has any info or could give me a hint as to what's going on here, it would be appreciated, because I'm kind of banging my head against the wall with it a little bit, because I do suspect that the IPC CAN is where all the command and control messages are going to be taking place. So I do have logs of this from the Saley and that up on the GitHub if you want to have a look. Okay folks, it's a really good job that I didn't bother with any of that resting stuff, because we actually made some progress. Let's have a look. Now, what we've got here is an Arduino DUI minus its CAN shield, because our trusty IPC CAN, as we know, doesn't use CAN transceivers. So I had another look at the logs from the Saley logic analyzer, and realized that the messages that I was seeing on what I called the kind of richer bus were similar to those that were on the other side of the bus, or however you want to call it. I'm really tired right now, so I'm probably not making sense. So, made a little resistor divider and connected the richer bus to the receive on the Dewey's CAN transceiver. And we started getting CAN messages then from our HV controller. Now, then, when we kicked on the PCS, we got more messages. And I thought, looks like the PCS is responding down the same line to the HV controller. Now, I realize I'm probably missing some very obvious point here, but you know, that's kind of me. So now let's have a look, and we've finally, and I mean finally, got the PCS to do something muttly. Okay, now there are two lines that go to the PCS called PWM charge enable and PWM DC-DC enable. The minute we are connected here to PWM DC-DC enable. And I've connected my analog discovery to that, and I was using it to put PWM and all kinds of frequencies and duty cycles and stuff in here, hoping this thing would burst into life in some kind of fallback mode. Sadly, that didn't happen. But then we got into some CAN reverse engineering. And let me see if I can show you this. Well, we've got here our message ID 224 and 204. These are being transmitted from the PCS to the HV controller over the IPC CAN bus. God, this sounds like a NASA love-in. Anyway, these messages look to be coming about 100 millisecond interval. There's no counters or anything going on in there. But observe message 224 when I change the state of the charge or the DC-DC enable pin from 5 volts to 0 volts. So you'll see byte 6 there changes from 10 to 00. If I go back to 5 volts, wow, look at that, from 00 to 10. Now, additionally, if we do the same thing to the charge enable line, message 204 byte 7 changes from 00 to 01, depending on whether we're at 0 or 5 volts on that enable line. So yeah, I know, not exactly the most fun-packed thing to have happen, but means we are getting some progress. Now, other thing to keep in mind is that what I had thought was a lower volume bus isn't. At the minute we're pushing between 2,300 and 2,500 messages per second on the IPC CAN. So it's definitely as busy as the charge port CAN. Now, I mean, I've just got these two enabled here, but if I hit enable all, then you know we get a real message fest here. Now, some of these are coming at crazy speed, so much so like that if you look at some of the reverse engineering data here, it says that there's no time between them, they're coming in that fast. So still not 100% sure what is going on with that IPC CAN bus, but at least we can listen to it. Now, I can't transmit on it, at least not yet. I think if I was going to transmit on the IPC, I would need to use the DUI to replace the HV controller. So that'll be our next job, because what I want to try and do is to see if I squirt a recording of the messages that the HV controller sends out into the PCS using the DUI over IPC CAN. Will the PCS respond to me? So got to work this out, but we are listening at the minute, so I'll count that as a positive. The other weird thing is that I don't seem to be able to use GVRET on a DUI by itself. It just basically hangs. I think it's looking for the little memory chip that's on the shield. So what I have to do is put the shield on, boot it up, connect, pull the shield off, and then connect here. So if anyone knows how to configure GVRET not to look for that EEPROM, then please do let me know. So we're not exactly pumping out 10 kilowatts yet, but we're slowly chipping away at this beast, folks. So thanks for sticking with me. So that is about it, guys, on our PCS hacking thus far. Remember Jack Rickard having a saying was that some days you're the bug and some days you're the windscreen. Well, you can guess which version applies to me today. Anyway, yeah, this IPC CAN is very, very weird. I want to get to the bottom of it. So anyone has any advice or ideas on that, then please do leave a comment. So I will leave you guys there. I'm probably going to walk away from this for a while now because I've got a ton of other projects to work on. And so, as I say, we'll get there, but the secrets of the Model 3 are many. So don't forget to dislike, don't share, and unsubscribe if you are subscribed. Check the links in the description for various suspects, GitHub, Patreon, PayPal, Open Inverter Forum, and whatever else I can throw in there. Trying to do anything too crazy, and until then, happy strange CAN bus signal decoding.